Okay, good. Let's get. All right. So what I'm going to do is I'll just give you a quick overview of the RTI features and the architecture and how RTI extends John, and then we'll get right to the demo so you can see RTI in action with John. RTI is an application performance management tool. Provides performance monitoring, alerting, and deep dive capabilities to measure how your application is performing and help you resolve problems. And RTI is designed to be used across the life cycle, not just in production. RTI can work directly with JBoss or Tomcat or Fuse servers, or as we're showing you here today, it can operate as a plug-in to the JBoss operations network. If you already have that up, you just drop RTI in and it starts working right away. The first thing RTI does is what we call business transaction discovery. Essentially, automatically discovers the requests entering your system and starts monitoring those and producing rate and response time metrics, which in the John environment, it starts pumping back to the John server, so you can use that for monitoring. At the next level, RTI produces a lightweight transaction profiling. This is designed to be very low overhead so that you can run it 24/7 in production. And this provides you with essentially a call summary profile view of your application, of the transactions moving through your application. And it's a great place to start deeper analysis of your application performance. And typically from the lightweight profile, you launch deep dive transaction tracing, the next level. And that's where we trace individual transactions moving through your system. We can even trace across JVMs, which we'll show you in the demo here shortly. And it basically produces detailed method-level diagnostics of what's happening. RTI also provides some support for doing resource metric analysis. We can extract metrics from the John server and also other metrics that RTI collects directly during a trace and present them to you to do other analysis. Again, we'll show you some of that. And finally, RTI extends the John alerting framework to provide an RTI capability such that when problems occur, you can automatically initiate one of these deep dive traces, for example, to collect information as a problem is occurring so you can analyze it later. When you use RTI in the John environment, there are a couple of interfaces you use. You use the John web console, as Matt's been showing you, and we'll extend that here. And you use that as a dashboard to look at the metrics and also to define the alerts and manage those. The second interface is the RTI console, and that's what you use for the analysis of the sort of the bulk performance data, the profiling and trace data. The RTI console is an Eclipse-based tool, so most developers are familiar with that, the interactions there. All right, the RTI architecture, this is sort of a picture of RTI installed in a John environment. Essentially, you install RTI on the hosts where you want to collect the information, where your servers are running. And as we said, RTI will start discovering the resources in your system and collecting metrics on them. In the John environment, you have the plugins which you install, one in the server for the alerts and one in the John agent, which actually you install on the server and it pushes it out to the John agents. And that hooks up RTI to John and allows the metric data to start being pumped into John where it's persisted in the John database. As you said, you use the John web console. You essentially log into the John server when you want to look at RTI metrics or manage alerts. And you do the same thing with the RTI console. You essentially log into the John server with the credentials, and that gives you access to the control and deep dive tracing information there. All right, we're going to move to the demo here. We have a demo application set up in the Amazon cloud right now. We're using JMeter just to push a test load as if we were doing a load test, for example. We have a Tomcat front end to the application. It's an e-commerce application that uses struts and has remote EJB calls from the Tomcat to a back-end JBoss server that's running there. And of course, we have the John server as well. For the demo and the analysis we do, we're going to focus on the Tomcat node. And that's just because that's the edge of our system. If we were responsible for the performance of the EJBs and the JBoss backend, all of the analysis that we're going to do, we could focus on just the JBoss backend if we wanted to. All right, that said, let's move to the demo here. The first view I'm going to give you is the John Web Console, which should look familiar again with the inventory, resource inventory down the left side here. As you said, when you install RTI, it begins collecting the metric information. It collects the information at an aggregate level for the Tomcat server in this case, and also breaks them out individually to all of the requests or business transactions that have been discovered. And you can see here in the summary dashboard pane the RTI metrics that are being collected. We basically have the transactions per minute and failures per minute, and then the average response time. So we get a feeling of what's happening in our application at the highest level. And as I said, we break these out into each individual transaction provides separate metrics for those. This is for the authentication request, and you can see, again, response time information. So metrics are a good way to sort of take the pulse of your application, and that's sort of the highest level of performance data we provide. To go deeper, we generally switch over to the RTI console. And this is the RTI console. We have our welcome page, which has a number of links to some common workflows you do with RTI, and we're going to go through a number of those in the demo. In the upper left here, we have what we call our collectors pane. And essentially, when you want to access the data, the RTI performance data is kept on the host where it's being collected, and you connect with the RTI console to those hosts to bring down the information you need. In this case, I have a connection defined for the Tomcat node. I also have one for the JBoss node. I have some other test nodes that I'm not using at the point. But you can see we have the same Tomcat collector for the overall application server, and then the individual transactions as well. We also bring in the other John resources, as Matt said, the platform resources, memory and file system, and things like that are accessible via the console. The last area of the console is the workspace here, and this is when you bring down collections of data. We build data sets so that you can persist that data and come back to it. You also can ship this data out, export it, and send it to a colleague who might be responsible for an area of performance, but you can do that, and that way everybody's working with the same data. All right, well, let's do some analysis. As I said, the first thing you might want to do is look at measurements, the metric values, and in this case, we're going to use the console to, again, we're connected to the John server, and we can bring down some of the metrics that are available here. I'm going to, for the Tomcat actual platform node, the virtual machine, I'm going to bring down a couple of platform metrics, and then I can also look at the RTI metrics here, and I can grab average response time and transactions per minute, for example. And now I send the request out to the John server to pull back some of the historical data over the past couple of hours here. As you can see, when I ramped up started the load test here, and all of the metric values start ramping up. So again, as I said, the metrics give you a nice way to look at the pulse of your application. As we'll show you later, it's also a way to define alerts to automatically detect what problems are occurring and collect data. The data in this table, you can save this table as a picture to include in a report, or you can actually save the data behind it as a CSV file if you need to export it into another tool. But this provides a good way to get at metric data. All right, the next level of data, as we said, is the profiling data, and I've started access the profile from the Tomcat node here, and this is what we call our profile editor. At the top is a profile table with all the transactions. We'll get to that in a second. At the bottom, you can see we have a couple of charts here. I think over here that is the platform system and user load, and the other RTI metrics over here. These charts work the same way. You can add more metrics to them if you want, and save them and all that kind of stuff. So those charts are about the same. So let's focus on the new information from the profile, and I'm just going to maximize that. As you can see, we organized the profile based on, again, the business transactions or requests entering your system. And this is, again, summarizing all of the requests that have been seen so far through this. You have the capability of resetting this profile to 0 over here. For example, you probably would do that before you begin a load test, then run your load test and look at the final table at the end to get a good overall summary. What we can do is, as I said, the profile is a good way to start analysis because it gives you an idea of which transactions are slow, how they're performing relative to each other, so you can focus your attention on the actual slow transactions. In this case, the authenticate request is my slowest one, so I might begin my analysis there. And what I can do is expand this and sort of drill down into what the transaction looks like. I actually can follow the light red nodes here to find the slowest path through the transaction, so I can actually focus my attention on there. This is a fairly complex one that we'll move through here. And eventually, there we go, we find that this transaction kind of moves through the struts and JSP layers, and then eventually there's an outgoing EJB call from the Tomcat node to the JBoss backend. Profiles are collected just for single JVMs, essentially. So in this case, I have a slow transaction. I'd like to know what's going on here, and it's a distributed transaction across nodes. So what I can do is use the deep dive trace to collect some information as the transaction moves through the entire system. I can start that trace here right from the profile, and what I do is I get some options on what I want to choose to trace to get the real detailed information. You can select your traces based on transactions, so that way you reduce the amount of data you have to sift through, and also in a production system it helps reduce the overhead for tracing. In this case, we just want to focus on the authenticate request, because that's what we're working on at the moment. We can filter out data again to keep the amount of data we have to sift through to a limit. In this case, transactions are the authenticate request is at 16 seconds. So I'm probably not interested in method calls less than 10 milliseconds. So that'd be a good set. And I can choose how long I want to do the trace to collect data. You know, I could collect it for the duration of the load test, or just for a few minutes on a production system. Again, to reduce the data and keep the overhead to a minimum. Once I've set my parameters, I request to start the trace. This sends the request again. We're connected through the JON server and out to the RTI running on the server to start the trace. It's all dynamic configuration. You don't have to restart or anything. All right, so normally I would have started my trace. I asked for a 5-minute trace, and normally I would sit here and collect and wait as the application is exercised, and I'd collect the trace data over 5 minutes. And then I specify that I want to bring the data back. Rather than sit and wait for 5 minutes, I've already have a trace that I did earlier and have downloaded the data. And the data is loaded into what we call our deep dive editor. At the top, we have a table which summarizes all the transactions we've seen. Again, we requested the trace just for the authenticate request, so that's what we see here. If we look in the lower left, sorry, the lower right, we see the chart showing the performance or lapse time of those, and you can see our average around 15 seconds, but we have some pretty slow transactions here. If we're doing performance analysis, those are the ones we want to look at. We also have some other, an overview timeline here, which kind of shows how the data was arriving. This particular data set isn't terribly, not a lot of concurrency in this one, but it gives us an idea of the shape of our data, which sometimes can help when you're doing load testing, for example. On this side, we have some summary views that show, in this case, we collected data from both the Tomcat front-end node and the JBoss back-end node so that we can find out what's going on. If we peek at the transaction data, we can kind of see on the Tomcat side. Again, we have the struts and JSP, and then outgoing EJB calls. If we peek at the JBoss data, we can see that we have the incoming EJB call, hibernate calls, and JWC queries. So that's sort of a quick look at our data. Well, let's dig in and see what we've got. As I said, we've got the requests up here, and we can choose to focus in on one of these and drill down into it by choosing focus or simply expanding that value. And what it does is show you the trees that move through our system. I'm going to maximize this table so we can take a look at it. Again, you can kind of see us moving through the request, individual request, moving through this Tomcat front-end struts JSP. Again, here's the outgoing EJB call from Tomcat, and here's the incoming EJB call on the JBoss side. And you can see it pretty quickly moves to an actual hibernate query where it's going to query the database and query the country table there. And actually, if you peek ahead, you can kind of see that, we see that it takes 10 seconds for this query in here, and this is the actual source of the query. at the hibernate level. If we peek ahead, we can see that the actual JDBC calls that are used to implement that query all actually finish pretty quickly. So we're spending a lot of time in the hibernate query, which may indicate that I've got a configuration problem with my hibernate or some issue there that I can look at. So that gives you an idea how you can kind of track these across JVMs and drill down, see source of requests, and map that to try and pinpoint where your problem is. If I'm paying attention here, I notice, okay, I've accounted for 10 seconds of the 22 seconds for this request. I'd kind of like to know where the rest of the time is. I can view all of these events as just a flat list, which is what I'll select here, and then sort it by the net time for each of them, I think. And then I can begin to track down where I'm spending the rest of the time. Here I have a slow JSP page. Some of these requests have a couple of hibernate queries, and they can determine if I have a problem there. All right, so that's sort of, let me get back. That's the deep dive event tracing that we can do. There's other information that we're collecting along with the trace here. We're collecting information about the garbage collection in the Java heap here. I'll show you this, scan this node. This shows information about both the JBoss and the Tomcat heap here. The JBoss heap is at the top. I think the yellow is the gray here is the heap usage in JBoss, and you can see that stays fairly flat, which looks good to me. The magenta here is the heap usage in Tomcat. Again, it seems to be within normal bounds here. The vertical lines are actual garbage collection cycles, so I can see how much time I'm spending in garbage collection. Most of them are about under 500ths of a second, so those would indicate minor collection cycles, which is good. But I do see one peak here where we've done a major garbage collection cycle, and it's actually in the Tomcat node. So these days you try and avoid major garbage collection cycles except for once a day. So it may be that I need to do some tuning on my Tomcat heap in this example. Let's see, the other thing we're doing is collecting other metrics, JMX metrics from MBeans and things like that. We can take a look, if we take a look in the JBoss side, for example, we collect them about EJBs, about data sources that were connected, JMS message pools, and things like that. If we could take a peek here at the EJB pools, we were looking at the country bean before, and we have information here about the performance. I can take any of these metrics that I like here and choose to plot them over on this metrics chart, so I can take a look at that. Here I also can get access to the metrics from this point to look at them. So I can do some analysis, for example, on whether I'm making full use of the EJB pool here, whether it's too big or too small for my test load, and do things like that. We have other summary information that we're doing. Of all of the database requests, we produce a summary table here so that you can take a look at the various Hibernate queries and get some summary of the overall performance of the different queries. We also have those down at the SQL level and JDBC level. We also compute method summaries here, so you can take a look at the performance of individual methods in your through the test to trace in this case, so you can look for hotspots either at the code level through methods, or you can look for hotspots for the overall transaction performance and things like that. So that's the trace information. Again, collecting a lot of detailed information, and again across the JVMs if that's required. The last feature I want to go through is the alerting, how we extend the JON alerting. In this case, we'll switch back to the JON web console. We were looking at the authenticate request, and it was slow. So we might have an SLA where authenticate is on average supposed to finish in 10 seconds or less. So we might want to set an alert to watch for conditions in that case. What we do is we use the JON alerting as Matt was showing you, and I'm just going to kind of quickly run through and show you how we could create an alert here, the demo. Again, the first thing is the condition or conditions where the alert will fire. In this case, we're going to monitor a metric value. As Matt said, we could use out-of-bounds metrics, that baseline computed by John. In this case, we'll just, since we have a hard SLA, we'll use that. So we want to be notified if the average response time for authenticate exceeds 10 seconds. We specify that in milliseconds here, so 10,000. So there's our condition. We just have one condition for this fire. And then the second half of alerting is the notifications, what to do when the alert does fire. In this case, as Matt said, there are a lot of choices. In this case, what we're going to do is use the RTI extension here to alert and automatically do a trace, say, for 5 minutes to collect some data as a problem is occurring on the system. There's some other parameters that, in general, just take the defaults in this case. So that's how I would define an RTI alert to do a trace, and that will automatically trace, collect the data, and save it on the John server. I also, as a notification, could send an email to let me know that, hey, I've got one of these performance alerts there. I'm not going to actually define this particular alert. I mean, we had one, if I go back to the list here, I had one just like this defined, and it's been running as we've been executing. And if I look at the history here, you can see that actually the alert has been firing because our average response time has been high. I'll just go back, as Matt showed you, in the dashboard view, you also get a view that alerts are happening so that a John user could know. But as you said, we could send an email or a track to somewhere else for notification. All right, so if I'm the performance engineer and I've been notified that either via email or a John administrator letting me know that RTI alerts are firing, I need to investigate that. So I go to the RTI console. Again, from the welcome page here, I'll choose Analyze RTI Alerts. I simply choose a route to the John server. And what I can do is choose a time period to look at what alerts are available. In this case, I'll just look at the last 30 minutes. If I knew I had a more exact time, I can zero in on that. So now I'll go to the John server and say, hey, show me all the RTI alerts for the last 30 minutes, and I get a nice list here. If I select from the list, it gives me a summary. Again, we define that alert just for the authenticate request where the average response time is greater than 10 seconds. At this point, it was actually 15 seconds, and here's the action I took. I did a trace for 5 minutes. And I actually have 2 snapshots of data, one from the Tomcat front end and one from the JBoss back end. Just as a point of interest, if I choose the most recent alert that just fired, I can see that I don't have a snapshot data. The 5 minutes is not up for that trace, so I don't have the data yet from that. But if I choose one that is ready, I'll go ahead and download the data, the trace data from the John server that saved during that instance there. And the console will download it, and then right now it's correlating the data from the Tomcat front-end node and the JBoss back-end node and building that together to give me a tree here. And relatively quickly, I should get that data loaded, and it'll load into the deep dive editor, which is what we were looking at before. Before we did a sort of a manual or interactive trace. This was a trace automatically performed by the by John in a condition here. We had a little bit of, mostly it's going to be these authenticate requests that we'll see. We have a few leftover things from the end of the trace here. But basically, if we took one of these authenticate requests, we could do the same kind of drill down, and we'd see we still have the same problem with the high rate because we haven't resolved it yet. But all that information, the metrics and the garbage collection data for that time period is collected as well, and all the other again, summary data is available as well from this. So that's alerts. That's pretty much everything. As we said, when you install RTI, it extends the monitoring capabilities of John, of course, producing per transaction metrics, rate and response time metrics. We have that lightweight profiling that gives you a kind of quick overview of all the data and begins your drill down process for looking for causes. And finally, the deep dive trace here that gives you very detailed information about individual transactions and lets you correlate that to problems in the code. And finally, you can use the John alerting to automatically collect data as problems are occurring. I think that's, I just have some final things. RTI is supported. We basically can collect data on Windows and Linux. We operate with all the current JBoss middleware platforms. We also have plugins for JMeter and SoapUI if you want to extend the tracing capabilities all the way out to test. We have an end-user monitoring one, plugin for browsers. You can extend our tracing capabilities right out to the browser and click to render tracing essentially. The analysis console that we've been using to look at the data runs on Windows, Linux, and Mac, and we're compatible with the current versions of JBoss Operations Network. We also, if you're interested, we have a full 31-day evaluation. You download the product and try it on your system and see what you can see, and we support you during that time period if you want to contact us.